All right, this video is going to go over the basics of the respondent conditioning process, one of the fundamental ways we learn and change our behavior through experience. The learning happens automatically. We don't have to do anything. We may not even realize it's happening, but as we'll see, our brain picks up on patterns and regularities in the environment. And for respondent conditioning, that means picking up on the fact that some stimuli show up around the same time as other stimuli. So in the last video, we talked about reflexes. We've got these to begin with. For example, a dog will just naturally salivate when you put food in its mouth. In Pavlov's original studies with dogs, he actually used meat powder. So he'd put the meat powder in a dog's mouth and measure how much saliva was produced. He had actually done a little minor surgery to add a drip tube to catch the saliva so he could measure exactly how much came out. Note that there are some stimuli we already have a natural reaction to, like the food naturally causing the drooling reaction, but there are also lots of stimuli that don't cause such a response, what we'd call neutral stimuli. For example, when Pavlov rang a tuning fork in front of his dogs, they didn't salivate, they didn't care. In other versions, he used the ticking of a metronome. And again, no salivating, no response. The sound was a neutral stimulus to them. However, Pavlov noticed something. His test dogs would sometimes start salivating when the technician came in with their food, came in with that meat powder, even before the dog got the food. Just seeing the technician seemed to start the salivation behavior. The dogs didn't originally salivate to the technician's presence. The technician used to be a neutral stimulus, so this was a new response, something the dogs had learned. Pavlov realized some conditioning, some learning had taken place, so he started systematically testing it. And that's where his kind of famous studies with dogs come in. So he realized the dogs might have learned that the technician always came at the same time as the food, or right before the food. A sort of warning signal or predictive signal that food was about to show up. So to test this systematically, he would take a neutral stimulus, like some sound that meant nothing to the dogs, the sound of a tuning fork or the sound of a metronome, and he would repeatedly pair that sound with the food when he fed those dogs. And what happened then when he rang the tuning fork and gave the dog food? Well, obviously the dog salivated, right? But that's because there's food in its frickin' mouth. The food caused the salivation, obviously. But here's where it gets interesting. When he had done this pairing of sound plus food, sound plus food, sound plus food enough times, he eventually tried making the sound without any food, just the tuning fork by itself. Okay? And so when he does the tuning fork by itself, what does he find? As you may already know, the tuning fork caused salivation all on its own. The dog started drooling to what used to be a totally neutral stimulus. It now had the power to control their behavior, to elicit a response automatically. But in this case, it's not a reflexive response. It's not something innate, but one that was learned, a response that was conditioned. So we say the sound, which used to be a neutral stimulus, we'll say it's become a conditioned stimulus, a CS, meaning a learned stimulus. It starts being a conditioned stimulus when it starts to elicit a conditioned response, a CR, which again just means a learned response, one that didn't used to happen to this stimulus. At that point, it's a CS eliciting a CR, kind of like a reflex, but it's a brand new learned or conditioned kind of reflex. And just a reminder of terminology, the salivating behavior here, the CR, that would be called a respondent. It's a respondent behavior, just meaning a type of behavior that's elicited by a stimulus, okay? Now let's practice applying those terms. I'm going to show you a funny little clip from a psych student, and afterwards you should actually pause this video and try to identify the US, the UR, the CS, and the CR in this situation before we move on. So let's watch this video.
Hey Psych 101 class, I'm David and I'm going to be testing Pavlov's theory of classical conditioning on my roommate Brian. The conditioned stimulus will be the sound effect.
That was easy.
And then I'm going to shoot him with this airsoft gun. He will soon learn the relationship between the sound effect and the shot before he gets too hurt.
That was easy. That was easy.
Ah!
That was easy.
Look.
That was easy. was easy.
All right, guys, looks like Pavlov's theory worked.
It's even funnier because I have an older brother named David who definitely would prank me like that. So, okay, pause now and try to identify the US, UR, CS, and CR. Okay, it can help to start with the reflex, with the thing that already existed before any conditioning or learning happened. So the painful stimulus, the painful pellet, right, feeling the pellet hit you, that's the unconditioned stimulus, the US, because it reflexively elicits a response, which is that kind of cringing and, of course, rubbing the painful spot. That would be the unconditioned response. This happens even with the very first shot when there's been no prior learning. So that's why we're saying it's unconditioned. We all would respond to this pain in the same basic way. Now, what the student in this video did was repeatedly pair up the sound, that was easy, with the painful pellet. The sound didn't elicit any sort of response the first time. It was a neutral stimulus to start with. There was no cringing to it, obviously. But after it showed up over and over again with the painful pellet, then some learning had occurred. The neutral stimulus had become a conditioned stimulus. So the that was easy sound became a CS, which elicited a conditioned response of cringing or covering his body to the sound by itself, even without a pellet showing up. That shows that some learning had occurred. That's respondent conditioning. Indeed, respondent conditioning is the idea underlying some of the most basic marketing techniques that we see every day. For example, advertising often pairs an unconditioned stimulus like attractive potential mates with the brand name or brand logo or a picture of the item they sell, which would be the neutral stimulus, right, that they're turning into a conditioned stimulus through repeated exposure to their ads. Basically, you could think of it kind of like a sexy body is the unconditioned stimulus that reflexively elicits positive arousal as a response. That's just natural. But the ad campaign is repeatedly pairing a sexy body, that unconditioned stimulus, with their brand, which may have started neutral but becomes a conditioned stimulus once the brand, once the CS, starts to elicit positive feelings as a response all on its own. That's respondent conditioning. That's classical conditioning right there. And even though you might think you're immune to advertising, believe me, studies show that you're wrong. Our brain makes these associations all on its own, behind the scenes, not necessarily in our conscious awareness. And yes, your behavior is affected. Now, let's step away from the applied realm for a minute and think more theoretically. What's really going on in this respondent conditioning process? Like, does the subject's brain basically just learn to substitute the CS for the US? In other words, does the brain basically start equating things like sound equals meat or tuning fork equals meat? Is that what's going on in the dog? That substitution idea, it's really reasonable, right? It's a reasonable way to look at things. It makes a lot of intuitive sense, but we've actually got quite a few reasons to think that's not the case. So first off, one piece of evidence that the CS isn't just a substitute for the US in the subject's brain is the way the CS elicits the CR, the way the tuning fork makes the dog drool, it does not follow the laws of the reflex. So if the tuning fork was equivalent to the meat and was just activating the existing innate salivating reflex dogs are born with, then it should follow the laws of the reflex we learned about earlier, the way meat itself does. But we don't find that. We find no law of intensity. So a bigger conditioned stimulus doesn't actually increase the conditioned response. A louder conditioned sound won't make the dog salivate more. It may even decrease the conditioned response because the louder sound is new and different. And we find no law of latency here. So with a stronger conditioned stimulus, we actually get slower latency to the conditioned response rather than faster. In other words, a louder conditioned sound means the salivating is delayed, whereas with the US UR kind of reflex, more meat actually does mean faster salivation. So that's one big reason to think that the CS isn't just acting as a substitute for the US, that's not what's going on in respondent conditioning. Another reason is that the conditioned response, the behavior we see in response to the conditioned stimulus, it may often be the same response as the UR, like salivating to the tuning fork the same way you salivated to meat, but that's not always the case. Sometimes the CR behavior, the conditioned response behavior, is a completely different behavior than the innate UR behavior, the unconditioned one. And that wouldn't ever happen if conditioning was just turning the CS into a substitute for the US. So for example, when you shock a rat, it reflexively leads to a jump or startle kind of response. We saw that in the video earlier, right? That's a reflex, a US eliciting a UR. But then, like Pavlov, you might repeatedly pair a sound with that US. So you pair a particular tone with the shock over and over and over again. Stimulus plus stimulus, stimulus plus stimulus, tone plus shock, tone plus shock. Eventually, you do your test to see if respondent conditioning has occurred. You play the tone by itself without any shock. And what do we consistently find with these poor shocked rats? The tone starts causing a behavioral response that it didn't used to when it was, just a neutral sound. So conditioning has definitely occurred, but the behavior we see to the tone, it's not what you might expect. They don't jump or act startled to that tone. Instead, the rat's exposed to a tone plus shock over and over again. They start to respond to the tone with a freezing behavior rather than a jump or startle response. So they've learned something new. Their behavior has changed based on experience, but their brain is definitely not treating the tone as if it's become equivalent to the shock. It's not substituting tone for shock. Otherwise, we'd see the response that goes with a shock. The tone doesn't become the shock during learning. The CS isn't just a substitute for the US. Perhaps a better way to think of it for now might be that the tone becomes a predictive signal that the shock is likely coming soon after. And that would explain why the rat freezes to the tone rather than jumps. In essence, it's waiting for the shock or maybe trying to hide from the shock rather than anything like, experiencing or mentally simulating the shock when the tone plays. Okay, so we've got our basic idea of respondent conditioning. And with practice, hopefully we can get comfortable using terms like US, UR, CS, and CR. But let's talk a little more explicitly about what's going on during this process and what happens when circumstances start changing again and we have to learn something different. So, first off, the actual learning during our basic respondent conditioning process, when that first happens, that's happening during a phase we'll call acquisition. This is where you're acquiring the new behavior or acquiring the association between those two stimuli. So this is where the CS and the US are showing up together over and over and over. Sound plus meat, sound plus meat, sound plus meat. The association is being formed in your brain, and that means during this process of acquisition, the neutral stimulus is becoming the conditioned stimulus. It's an active process. So here on the graph, if you look at the y-axis on the left, we're measuring the salivating response, right? How many drops of saliva there are. But as you can see, it's saying how much salivating happens for the CS itself, just for the sound without the meat. So by the second trial, you can see there's already a little bit of salivating to just the sound without the meat, right? And you can see that the learning happens pretty quick. So this graphic goes up pretty fast. In this case, it looks like it only took around 4 to 6 trials to start getting 10 plus drops of saliva out of the sound itself on tests where there was no meat coming with it. In other words, what we're graphing here is how strong the respondent conditioning is. So this is the acquisition process getting up to this kind of maximum high point at the top. Now eventually the CR, the response to the conditioned stimulus, that would be the salivating here, that's going to max out basically. It approaches an asymptote. And even with additional CS-US pairings, even with more experience of bell plus meat, bell plus meat, bell plus meat, the CS won't really elicit more of a CR. It's maxed out. And if you're wondering what determines that asymptote, like what determines what that maximum is, it's determined by the magnitude of the unconditioned stimulus. So to stick with Pavlov's simple example, more meat during the CS-US pairing of sound plus meat, sound plus meat, sound plus meat means we'll get more salivation response to the sound itself. So we'll get this chart will basically go up higher if we're using more meat for the US, or just a more preferred unconditioned stimulus. Or for another example, we find that a bigger shock during the US-CS pairing of shock plus tone, shock plus tone, shock plus tone, a bigger shock means we'll get more freezing response to that conditioned tone stimulus. It'll go up eventually higher, right, after some learning. Now, how do we know how strong the CR is at any given time? In other words, how would we measure drops of saliva elicited by CS in the graph above? Like, yes, Pavlov had set up he had done a little surgery and set up a little drop tube, a little tube coming out of the dog's mouths to measure how many drops of saliva there are. But the question is, what are we actually doing in each trial that will then go and measure for that trial the drops of saliva? Like, how do they make this graph? Maybe take a moment, try and think about it by pausing the video, and then I'll give you the answer. So basically what we do is we just occasionally insert a test trial, sometimes called a probe trial, among all those CS-US pairing experiences. So among all those trials where we're going sound plus meat, sound plus meat, sound plus meat, we'll occasionally insert a test trial where you present only the CS, so only the tone, and see how much of a conditioned response there is, how much they drool to just the tone. We need to do this because during the normal pairings, during the trials with the learning itself, the unconditioned stimulus is present. The meat is there. So we don't know if the dog is doing its salivation response to the sound or to the meat or to the mix of them. But in a test trial with only the sound and no meat, we now have a measure of how much power the CS itself has gained, how much learning has occurred related to that previously neutral stimulus. So that's basically how this acquisition graph is made. Now, here's a pretty important question then. What happens if you keep presenting the CS by itself without the US? In other words, play the sound without any meat and the dog drools. Cool, okay, it's learned something. Play the sound without any meat and the dog drools again. Okay, the CS will keep eliciting the CR, the conditioned response, for a while, but if you keep presenting it without the original US, without the meat, eventually the CS stops causing the CR. And this is a phenomenon we call extinction. We'd say the learned response is getting extinguished. It's going away. So extinction is the reduction of the conditioned response when the conditioned stimulus is presented alone over and over again without the US. You can see in the blue line of the graph here how many drops of saliva the dog is producing when it keeps hearing the tuning fork but not getting the meat with it. It's getting sound but no meat. And if this keeps happening, that salivating response, the CR, it drops off quickly. That's extinction. And your intuition might be to interpret that, what we're seeing here, as unlearning or forgetting, right? That makes sense. It seems like the dog is unlearning the sound plus meat association. But something weird happens after we've extinguished the CR at the end of this graph and we go home for the day. If you come back tomorrow, and for this dog that you already did extinction, you got it down to where it no longer salivates to the sound, come back tomorrow and make the sound, you would expect that the sound will still cause no salivating because that's where the graph was at the end of yesterday's extinction, right? And yet, this is the purple line here is what we see. After some time has passed, if we try the CS by itself again, so the tuning fork without the meat, the CR comes back. It comes back at least partially. They start drooling to the tuning fork even though we had extinguished that. We thought we had undone all the learning, right? So this phenomenon, the purple line here, it's called spontaneous recovery. Even after extinction, when it seems like the CS doesn't elicit the CR anymore, if some time passes, like taking a long break or sleeping, then presenting the CS will start to cause the CR again briefly. That said, the CR will quickly extinguish back down to nothing after just a few exposures to the CS without the unconditioned stimulus, without the meat. So if you keep doing this, you're doing the tuning fork, it might make them drool for the first couple trials on this new day, but it doesn't take long before it causes little to no drooling again. And indeed, this same thing will continue for a while. So even after we do extinction again and get the purple line down to 0, another day of resting and we get a bit of spontaneous recovery again. So as you can see with the green line here, although clearly it's less of a recovery and the CR is extinguished again even faster this time. So, okay, what do we learn from this phenomenon of spontaneous recovery? Why is it important? Basically, it shows us that the initial extinction period does not fully erase the learning. And the learning wasn't just forgotten over time. It's still there. The association was still there in the brain even when we'd extinguished it down to 0 conditioned response at the end of the blue line or at the end of the purple line. Indeed, it might still be there at the end of the green line. but no longer causing the response. This is why many definitions of learning say relatively permanent change. All of those changes in the graphs here are learning, the ups and the downs. That's all learning because the behavior pattern is changing. But the learning during extinction isn't just an unlearning or an undoing or an erasing of the original learning that happened in acquisition. There's actually plenty of other evidence that extinction is not simply unlearning the acquisition. I'm going to cover a couple of phenomena that provide such evidence. For example, one of these phenomena is called renewal. Renewal is when, after you do extinction, but maybe in a different context or situation, like a different room, the response returns when you go back to the old original context. So think of it like this. Let's say in the red room, that's our first context, we do the acquisition process. In the red room, we play a 1000 hertz tone and then shock the rat. And we do this over and over and over again in context A, in that red room. In the red room, tone plus shock, tone plus shock. Then, after the rat has learned that, right, after the rat has gotten scared of the tone, then we bring the rat to a room painted blue. In the blue room, we'll call it context B, maybe we play that same 1000 hertz tone, but without any shock, just the tone by itself. And yes, the rat freezes. Of course it does. It had learned the tone was scary. But maybe we keep doing this. In the blue room, we keep presenting the tone with no shock, presenting the tone with no shock. And eventually, the rat stops freezing to that 1000 hertz tone since no shock is happening. That's extinction. But here's where it gets weird. If extinction was unlearning, then bringing the rat back to the red room and playing the 1000 hertz tone by itself shouldn't cause any freezing. After all, there's no shock anymore. We've done extinction. Yet, what we find is that if you go back to context A, go back to the original, the red room, the CS by itself starts to elicit the CR again. In other words, the tone becomes scary again, even though we've done extinction. We just extinguished it in this other context in the blue room, but go back in the red room and the tone's scary again, even without a shock. That's renewal. The response is renewed by going back to the original context, which could be an environment, like a room, right? The color of the room or something like that. Or it could be any situational context, like who or what else is present, what time of day it is, whatever we mean by context. And indeed, renewal doesn't just happen when you extinguish in one context and then return to the original acquisition context. It also happens if you do the acquisition in one context, then the extinction in a second context, then simply go to a novel third context. So let's say you do the tone plus shock in the red room, they acquire it, they get scared of the tone. Then you do extinction in the blue room, tone by itself, becomes totally safe, they're not worried about it, they don't react to the tone anymore in the blue room. Then bring them to a new context, like a green room. And in the green room, play the 1000 hertz tone. What do we find? The rat will freeze, even though we extinguished the response previously, and even though the rat isn't back in the original context, that still counts as renewal. So that's why I put here, it's after extinction in a different context, the response returns in the old context or in a completely novel third context. So that's renewal. That's another example showing us why extinction can't simply be an unlearning, that when we're getting rid of that respondent conditioning, or getting rid of that response to the conditioning, that's not an unlearning or a forgetting. Here's one more phenomena that supports that really tells us extinction is not unlearning. So this one's called reinstatement. After extinction, so after you've been doing the CS by itself without the US, doing the tone without the shock, or the sound without the meat, if you happen to present the US on its own, out of the blue, totally disconnected from the CS, if it just happens to show up again, you'll find that the CS may start to elicit the CR again, even after you had extinguished it earlier. So let's say, for example, you're Pavlov, right? You do the acquisition phase. You do bell plus meat, bell plus meat, bell plus meat, bell plus meat. The dog learns to salivate to the bell. That's acquisition. Then maybe you take a while to do some extinction. So you do the bell by itself, the bell by itself, the bell by itself. Eventually, the dog doesn't give a crap about the bell anymore. That's extinction. But then, Maybe one day later on, randomly you give the dog meat for dinner. Something it hasn't had in a while. Instead of its usual kibble, some meat shows up. Now that that's happened, if later that day we ring the bell by itself again, totally disconnected from the meat, just random bell by itself, the one that the dog didn't give a crap about anymore, suddenly it salivates to the bell again. It salivates the way it used to, just because of that random exposure to the US. That would be reinstatement. So the conditioned response ends up reinstated simply because the US showed up on its own. Or another example would be a rat, where maybe you pair up tone plus shock, tone plus shock. The tone is sort of a warning you're about to be shocked, right? You do that over and over and over again until the tone causes the conditioned response. The rat freezes to the tone. Then you do extinction, play the tone by itself, no shock, just the tone, just the tone, just the tone, until it no longer causes the conditioned response at all. The rat may appear to have unlearned the tone plus shock association, right? At the end of extinction, it's going to seem like the rat has unlearned the tone plus shock association, so you might think the info is gone from its little rat brain after this. But if one day, out of the blue, the rat gets shocked randomly, maybe it just steps over a loose wire or something like that, gets just a random exposure to the unconditioned stimulus, a random shock. What happens if you later on test the tone by itself one more time? The tone makes the rat freeze again. That's reinstatement. Now, clearly renewal is all about different contexts between the acquisition and the extinction and that later testing, right? For example, the contexts are A and then B and then back to A. Or in the other version we saw, the context might be A and then B and then go to some new room like C, right? The green room. Given that, just thinking about these things we've learned now, how might spontaneous recovery be seen as really similar to renewal, or perhaps even a special case of renewal? I suggest you pause for a moment and kind of speculate about that. Well, if you think about it, in spontaneous recovery, we had different contexts, where the context was not a different room, like a red or blue room, but a different time. So time can be part of the context just as easily as a different room or a different experimenter or anything else. As behavior analysts, we try not to anthropomorphize or make assumptions about internal cognitions when we can help it, but just to sort of pump your intuition here, you might put yourself in the shoes of Pavlov's dog, going through all these experiences and trying to figure out if the sound is going to get you meat or not. So early on in the first day of Pavlov's experience, during the acquisition phase where the graph is orange here, the dog's brain is getting some evidence that the sound predicts meat. So no wonder it starts salivating to the sound. It's got a lot of evidence that the sound predicts meat coming. But later that day, for the blue line, the rules seem to have changed. The dog's brain is getting more and more evidence that the sound does not predict meat. So now it's got two sets of contradictory or competing evidence. One from the morning of that first day and one from later that first day. Okay, now when the dog goes to sleep and wakes up the next morning and the sound happens, in other words, on the first trial of day 2 here, will the dog's brain expect meat or not? And think about this from the dog's perspective. Some past evidence says yes. After all, for much of yesterday, the sound predicted meat. But some past evidence also says no. After all, in the most recent experience yesterday, the sound was not predicting meat. So in some sense, based on that uncertainty, the dog's brain kicks in a sort of middle ground response. It salivates somewhat, but not as strongly as it did at the end of acquisition, and certainly not as weakly as it did at the end of extinction. Then, based on what happens in that first trial, some more evidence is accruing, right? And this time it's evidence from the same day. So on trial 2 of the purple line, after that sound didn't produce any meat on trial 1 of that second day, we're going to get less salivating. And on day 2, the evidence just keeps accruing that the sound doesn't predict meat, right? Now, keep putting yourself in the dog's shoes, so to speak. And what happens when it gets up on the third day and it hears the sound right at the start of the third day? The brain still has memory traces of that original acquisition, and it has more recent memory traces of the sound occurring without any meat, right? So maybe it's going to weigh that more recent evidence more heavily. The brain still has some uncertainty, but its best guess is that the sound probably doesn't predict meat. So what we get is maybe a very minimal CR, very little salivating, just a little bit to kind of test the waters, so to speak. See what the rules are today, you know? And assuming that the sound keeps happening without meat, because that's what we're doing in this test here, assuming no new evidence shows up to contradict that, then the brain will become more and more sure that the sound no longer predicts meat. That makes sense. It's just adding evidence and kind of weighing that evidence to predict what's going to happen in the world. So that means the dog has not unlearned any of the evidence at all. It hasn't forgotten or unlearned the orange line or the blue line or the purple line. It's just looking at all the combined evidence, all of the combined memory traces, and perhaps weighting the more recent evidence the strongest, or experiences that happen in the same room might get weighted the strongest. So with renewal, when I'm brought back to the red room where acquisition happened, it makes sense that my brain's best guess becomes more weighted towards thinking the prediction is still valid, even if I've recently been extinguished in some other context, some other room, which may not be treated as quite as relevant by my brain. So really, all three of these phenomena, spontaneous recovery, renewal, and reinstatement, all three of those can be looked at as the brain just weighing the available evidence from past experience and eliciting behavior based on its current best guess of what stimuli will or won't show up together in the current context, whether some meat will come, whether a shock will come, whatever. Okay. That's enough about the basics of respondent conditioning. Our brain picks up on associations between things. Specifically, it seems to notice when one stimulus predicts another consistently. But it's also laying down connections in the brain relating to the context of when we experience those two stimuli together a lot. And it takes those contexts into account when faced with uncertainty. When a CS occurs and the brain has to guess whether that is predictive of the US coming or not. So in the next few videos, we'll actually build on this basic idea of respondent conditioning with some more details. For example, by seeing what happens when we encounter something similar to the conditioned stimulus, but not exactly the same.